Section 2.3, Permutations with Constraints. We're going to look at some examples where there are two or more objects that must be placed together, two or more objects cannot be placed together, and certain objects must be placed in certain positions. Example 5. A hockey team is lining up in a row for a group photo. Their team has one goalie, 4 defense, and 7 forwards. The photographer wants the defense on one side of the goalie and the forwards on the other side. How many ways can the team stand in a row for this position? So we have two things to consider. First of all, we want the goalie in the middle. We can have the defense on one side and the forwards on the other. There are 4 defense, so there are 4 factorial ways to arrange those 4 defense players. There are 7 forwards, so there are 7 factorial ways to arrange the 7 forwards. And again, there's only one way to place the goalie. The other situation we can have is we can have the goalie in the middle, and there's only one way to do that. And the forwards can go to the left, and the defense can go on the right. Same reasoning, there are 7 forwards, so there are 7 factorial ways to arrange 7 forwards. There are 4 defense players, so there are 4 factorial ways to arrange the defense players. So we can have case 1, or we can have case 2. So we can find the total number of ways in each case and add them together, or we can find 1 and multiply it by 2. So here we have 4 factorial times 7 factorial, and we can say plus 4 factorial, 7 factorial, or we can write that as 2 times 4 factorial, 7 factorial. That gives us 2 times 24 times 5,040, giving us a total of 241,920 ways to arrange the players on the hockey team in a line for a photograph.